Good evening, students. Today we will be discussing an important concept in operating systems that is mainly known as inter-process communication. We will be seeing what is the meaning of inter-process communication, what is the main necessary for inter-process communication, how do process communicate with each other, what are the different mechanisms that are used by process to communicate among themselves. Now moving on to the concept, let us see what is inter-process communication. As you have all heard about this term, this may be new to you, but as we have already discussed in the previous video about how a process is created, what are the different states that a particular process should move on to from the starting state to the termination state. Now let us see what is inter-process communication. Speaking generally, inter-process communication is a type of mechanism that is provided by the operating systems. The main aim or goal of this mechanism is to provide communication between the several processes. In short, the intercommunication allows a process letting another process to know that some event has occurred. As you can see in the diagram, there are two processes P1 and P2 which are connected to each other with the help of inter-process communication. For example, let us take that a process P2 had requested some input output operation to be performed. As you all know that for a particular device, then working with the CPU, attending and fulfilling the request of input output operation is very necessary. So when a particular process receives an input output operation request, it will immediately disconnect its movement with the CPU. It will go and attend the requested input output operation. So if particular process P2 went to communicate or fulfill the input output request, it should immediately communicate that particular message to the process P1. So generally, if this IPC mechanism is not present between the process, they cannot communicate with each other, which will be a very hectic task. To avoid this particular task, the operating system had established a feature of inter-process communication between the process, where they have the chance to transfer data between one process to another process. Along with the transfer of data, they can also communicate with each other to share some important things. In general, it is a mechanism that is inbuiltly provided by the operating system. Inter-process communication can also be used for exchanging useful information between numerous threads in one or more process or programs. This inter-process communication not only helps in the transferring of messages, but it will also help to transfer some of the important data. For example, for the process P2, let us take for process P2 for completion of an input output operation, it requires a particular resource R, where the particular resource R is only available with the process P1. So the process P2 with the help of inter-process communication will send a message to process P1. Dear process P1, I am in the need of resource R. Please send me this resource so that I can fulfill the requested input output operation. Immediately, as a response to the message received from process P2, the process P1 will immediately send the required resource to process P2, as a result of which the process P2 will happily satisfy the input output operation which it has been requested for. On moving on further, we will see what is synchronization. Now, we have discussed what is the concept of inter-process communication. To avoid conflict between the process, as I have already told in my previous video, my dear friends, when there are many processes which are generated and are waiting in the main memory to get a chance to work with the CPU, there may be many conflicts arising between the process that had been generated, like which process should be promoted first to go and work with the particular CPU. To avoid this particular conflicts, there is a mechanism which is called as synchronization mechanism in operating systems, where this synchronization mechanism sees that the conflict between the process is resolved and the mutual exclusion is established between the process, so that they can go one by one access the CPU, complete all the requested operations by the external user, and the process can reach to the state of termination. So, semaphore, mutual exclusion, barrier, spin lock, these are some of the important synchronization techniques. Don't worry, my dear friends, we will be making a separate tutorial regarding the synchronization mechanisms in operating systems, where we will be looking in much more detailed about all these concepts of semaphore, mutual exclusion, barrier, and spin lock, along with the introduction of the concept called as critical section, which is a heart of the operating systems. This all synchronization topics and related stuff will be discussed in the upcoming videos. We on moving further, we will see what are the different approaches that are available for inter-process communication, IPC. As we have discussed that IPC is nothing but inter-process communication. How is this communication done? You can now see that there are many, so like suppose if you want to establish communication between two human beings, you can easily establish, like we have many options. You can establish using WhatsApp, you can establish using text messages, you can establish using a video call, you can establish it may be a physical talking. But we are telling that communication is taking place between two process. How is this communication taking place? What are the different approaches that are available for this particular process to take place, that to further communicate with them? So I think mainly there are two types of communication approaches that are available for this particular process to communicate between each other. The first one is, we will be discussing about the first available communication technique, that is called as pipes. As we all know, what are pipes? Generally, when I tell to you about the word pipe, you will immediately get an idea will be coming into your mind. Yes, what is pipe? Pipe is a cylindrical shaped structure or object which is mainly used for the flow of, like generally it is used for flow of water, or it is used for flow of information. You will tell that water pipes, there is a water pipe connected from the tank to the tap in my house. Generally, you will be getting an idea of pipe. Yes, you are right. What idea that has come to your mind is absolutely correct. Pipe is similarly, we the concept of pipe is same in operating systems. A pipe is a data channel that is unidirectional. Two pipes can be used to create a two-way data channel between the two processes. As you have all seen, pipe is a data channel or a cylindrical like structure that helps within the process to connect among each other. It helps to transfer information between each process. This particular pipes help to transfer the important data. It is also a pipe can be also referred as a temporary software connection between two programs or commands. So this pipe also very plays a very important role between the process communication. In this pipe, we have mainly two type of communication techniques. That is, pipe can help us to do one way communication, or else it may help us to do two-way communication. Okay friends, it may help us to do multi-level communication or single level communication. Now we will see more detailed message passing techniques using pipes. It is a mechanism for a process to communicate and synchronize. Using message passing, the process communicates with each other without resorting to the shared variables, which means that with the help of pipe, there will be sharing of data between the two process. See, once the data is shared from one particular end of the pipe to another end of the pipe, it cannot be read. And also, I'm telling you, my dear friends, pipe will establish a communication called as one-way communication between the process, where you can see in the diagram there is only one end of the pipe, one process is writing, and on the another end of the pipe another process is reading. So which means that whatever data that is written by one particular process will be written on one side of the pipe, and once the particular data that the process want to convey to another process is written, then the right end of the pipe will be closed. So immediately it will the read end of the pipe will open, which means that the process that is present at the read end will take the information that is written by the process that is present on the left side of the pipe. Now we can establish two-way communication also using these pipes. So how is this two-way communication established possible? Let us see how this two-way communication can be established in a detailed way in the upcoming videos. But as of now, you just remember what is pipe, what are the two ends that are available to a pipe, and how the information is retrieved using pipe. Now, as I have told you, not only pipes, there are many inter-process communication techniques that are used by the process to communicate between each other. Now, after pipes, one of the important inter-process communication that is used is message queue. The one of the important thing that we can see is that is the message queue. One of the important communication that we can see is the message queue. So, okay, students, on moving on to the next inter-process communication, that is using the message queue. Now, let us discuss what is message queue. A message queue is an inter-process communication mechanism that mainly allows the process to exchange data in the form of messages between two processes. Now, as we have discussed previous that we are telling that some data is being transferred between the two processes. Have you ever noticed what is the data that is being transferred? What kind of data is being transferred, or how is the data being transferred, in which form the data is being transferred? When discussing mainly about message queues, the data is transferred in the form of messages. So it allows the process to communicate asynchronously by sending messages to each other, where the messages are stored in a queue. As you have understood this concept very clearly, this particular inter-process communication technique has received a name called as message queue because the data between the two processes that are communicating with each other will be transferred in the form of messages, and the messages that are transferred between these two processes will be stored in the queue, message queue. That particular queue is called as message queue. The message queue is a buffer that is used in non-shared memory environments where the process communicate with each other. Now, the particular message queue is an unbounded first in first out queue that is protected from concurrent access by different threads, which means that process A had sent a message to process B using the inter-process communication technique called as message queue. When particular process A had sent a message to process B, and this message had gone into the queue and it is waiting in the queue, no other process or no other thread that is present in the operating system can access the particular message queue when already a process is being when it is when already a process is being accessing that particular message queue. Now, in the concept of message queue, we are having many commands. As you can see on the diagram, there is a diagram where the message is being sent, and it is being passed on to the module. Now that message from the module is going into message queue, it is going to the message passing module, and the particular process is receiving the message. Now we are having different functions. When we write a program for this particular message queue in a compiler, we are having different functions. Some of the functions are message get, msgget, close and open parenthesis. This particular message get function is a function that is used to create a new message queue, which means that for a particular process to communicate between each other, they are having so much messages or so much data to share between each other. One queue may not be sufficient. So by using this message get command, we will be creating one more queue, that is a message queue for exchange of messages. Next, new messages are added at the end of the queue by message send. Suppose I will be writing message send, open the bracket, I am process 1, again close the bracket, semicolon. Now whatever message is written inside this particular message send function, this message will be transferred into the message queue and another process will be reading that message. Now the process, the parent process or the first process which had sent the message to second process will be in a dilemma. I have sent the message, whether that particular message has been reached or not, it should understand, right? It should first of all get a confirmation that whether the particular message had reached the other process or not. For that there is a command called as message receive function, msgrcv, open and closed parenthesis. This is a message receive function using which the messages are fetched from the message queue. Suppose process p1 had written a message into the message queue. Now for the process p2 to fetch that message from the message queue, it have to use the message receive function. So these are some of the important functions that we have discussed and that are also used in the message queue concept. Now we will be moving to one more important concept in operating systems, that is called as that is also a particular inter-process communication technique, that is mainly called as shared memory. Message queue and shared memory are like both hands of the operating system, which mainly help the process to communicate between each other. Now moving on to the concept of shared memory. What is shared memory? Shared memory is a memory that is shared between two or more processes. Each process has its own address space. If any process wants to communicate with some information from its own address space to other process, then it is only process possible with inter-process communication techniques. As we all know, when compared with message queue, shared memory is a very faster technique for inter-process communication. For better understanding students, I will tell you a practical example. Now, the notice board that is present outside your classroom in the college or school is a best example for shared memory. Your particular coordinator or your subject coordinator or your floor in charge will bring the notice and he will paste that particular notice on the notice board. Now all the students of the particular campus or all the students of the particular class will go and read the notice, which means that here the notice board is acting like a shared memory. Whatever content that is stored in the shared memory, all the process at a time will come and read the content that is present in the shared memory. It is the fastest inter-process communication mechanism. Now a particular, as you have seen the as you have seen the diagram, the among the kernel there are two process, process a and process b, and process a is writing into the shared memory. At the same time process b reads from the shared memory, which means that both of the process are using the same part of the memory. They are sharing the memory, that is why it is called a shared memory. The amount of memory that is available is being shared between the process, so it is called as shared memory. And they are doing the work simultaneously between the process. One process is writing into the shared memory, at the same time another process is reading into the shared memory. So we told that shared memory is one of the fastest communication techniques than compared to message queue. Now, as you have all known, we have seen some important functions in the message queue IPC mechanism. Similarly, there are some of the functions that are available in shared memory. Mainly, there are only two function calls that are available in the shared memory: SHM get and SHMAT. SHMGET, open and closed parenthesis, is one function, and SHMAT is one function. In the coming to the SHM get function, it is mainly used to get the shared memory. It is used to create the shared memory. As we have all seen in the message queue, MSGG message get is used to create the message queue. Similarly, SHM get is used to create the shared memory for the usage between the process. And similarly, SHMAT SHMAT is mainly used to attach the shared memory, is mainly used to attach the file that is created to shared memory. Suppose I have recorded a video and I have saved that file in my computer. Now that file that is being saved in the computer should be moved on to the shared memory. I have to take out that file and I have to move that file from the location in the laptop to the shared memory. I will be using SHMAT function which will attach the file to the shared memory segment that is associated with the shared memory identifier. Each created shared memory will have a unique ID to each other, which is called as SHM ID, which is referred as shared memory ID, which is unique to each and every created shared memory. After this particular usage of shared memory, there is a function called shared memory detach, where once the particular process had used the memory and the usage of this memory is being completed, there is when you think that there is no more use for this particular process had used the shared memory completely, there is no more use. So this particular shared memory will be detached or will be killed by using the shared memory detach function. So these are the very two important interprocess communication techniques that you have discussed, that is the shared memory and message queue. Now we will be seeing direct communication. As you can already understand from the term direct communication, each process that wants to communicate must explicitly name the recipient or sender of the communication. So the process will be directly communicating. Like our process will be sending the message, it will receive the reply. There is no special mechanism that is involved in this direct communication. But while coming to indirect communication, we have already discussed now. Indirect communication may be taking place using shared memory or message queue. Okay, students. Now this particular interprocess communication, we have discussed that interprocess communication between the client and server will take place using message queue. This message queue will always follow the principle of queue. What is principle of queue that you have learned in data structures? First in, first out, or a variation on a pipe that creates a more flexible communication structure. Whatever the data is sent, that is first sent into the pipe will be the data that used to be come out. FIFOs are created by one process that calls MK FIFO. MK FIFO is like it is instructing the message queue to follow only the FIFO order. So, as you all know, the queues that are created in the message queue will always follow FIFO order. I once again tell you, inter-process communication is mainly established using two things: shared memory, message queue, pipe. As of now, pipe is not used. It is also a very good interprocess communication technique, but as of now, the most famous interprocess communication techniques are message queue and shared memory along with pipe. So, thank you, friends. In the upcoming video of our tutorials, we will be discussing mainly about the process synchronization techniques. What are the different mechanisms that are available for process synchronization, and what are the issues that are mainly faced to resolve the conflicts between the process, and we will be mainly discussing what is a critical section. Thank you, my dear friends.